Hello friends, so far we have learned different trigonometric identities, basically three trigonometric identities and the complementary angle pairs and their trigonometric ratios. Now we will apply this knowledge, this chunk of knowledge that we have in solving some questions that appear to be calculation based. That is, on seeing these questions you will say that we have to calculate sine 26 degree its square, and will be adding that square in another sine of 64 degree whole square, and will be doing calculations. But actually, by applying the identities, these questions are really very easy to solve. In fact, much of the calculation part, the calculation portion, will be removed if we apply properly the identities and the rules of complementary angles. So friends, let us rewind what we have learned in complementary angles and trigonometric identities. We have learned three identities. The first said sine square theta plus cos square theta equals 1. Second said secant square theta minus tangent square theta equals 1, where theta is the angle of interest. And the last identity, the third identity, said cosecant square theta minus cot square theta equals 1. Apart from this, the complementary pair said that if we have sine theta, then it will be cos of 90 minus theta, and similarly if we have cos theta, then it will be sine of 90 minus theta. Similarly, complementary pair was formed between tangent and cotangent and secant and cosecant. So let us start our first question and check and know how we can apply these two bits of information, the identities and the complementary angle T ratios. Now the first question says sine square 26 degree plus sine square 64 degree over cos square 27 degree plus cos square 63 degree. Friends, we know the value of sine of 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. But we don't know such kind of values, that is 26 degree or 27 degree. But if you look clearly at the numerator, you will find that 26 plus 64 is 90 degree. So somehow we should apply, or at least try to check whether the complementary angle solves our problem or not. So the numerator here is sine square 26 degree plus sine square 64 degree. Apply complementary pair to any part. First of all, let this sine square 26 degree be like this, the square moving to outside the brackets. So on applying complementary pair, it will become cos of 90 minus 26 whole square, that is cos of 64 degree, because 90 minus 26 is 64 degree. So, or cos square 64 degree. So bringing this part also, we are left with sine square 64 degree and cos square 64 degree. That is, angle has become same. Now check this identity which says sine square of the angle and cos square of the same angle is 1. So by the first identity, this part has become 1. That is, numerator is 1. Similarly, if we check the denominator, cos 27 whole square can be written as sine of 90 minus 27. Now 90 minus 27, you will find out that it is 63. So it has become sine square 63 degree plus cos square of the same angle. So again, applying the first trigonometric identity, this part has also become 1. So the question has become 1 by 1, that is 1. So the answer of this question is 1. Let us check what is in store in the second question. The question says 16 secant square a minus 16 tangent square a plus 16 sine square a plus 16 cos square. Now first of all, see, in this question, let it be denoted by Q. 16 is common in all the terms. So take 16 common outside the brackets, and we are left with secant square a minus tangent square a plus sine square a plus cos square a. Now clearly see this second identity. It says secant square theta and tangent square of the same angle when subtracted, that is secant square theta minus tangent square theta is 1. So clearly here the angle, that is A, is same, and therefore this pair will reduce to 1. Similarly for the second pair, by using the first identity, it says sine square and cos square of the same angle when add up will give 1. So as a whole we have 16 into 2, that is 32 is the answer over here. So the answer is 32. Let us check the third question. The question says, well, it's a very long question. Let us first solve this part. Let it be denoted by Q. So Q, this first part. Here again you see that 44 plus 46 is nothing but 90 degree. Similarly in the denominator, 47 and 43 will add up to give 90 degree. So again you are prompted to apply complementary ratios here because of the sum being equal to the complement 90 degree. So apply here the complementary rule. What we get? See, in the complementary rule, secant was complemented to cosecant, that is secant and cosecant follow the complementary rule. So in the numerator we have secant 90 minus 40, secant 44 is cosecant of 90 minus 44, and since it is whole square, so put whole square outside, minus cos square 46. Similarly in the denominator, cosecant can be converted to secant, so we have secant 90 minus 47 whole square minus tangent square 43. Friends, 90 minus 44, as we have already seen here, that it will give 46. So we will be having cosecant square 46 minus cot square 46 over secant square 43 minus tangent square 43. Friends, in the identity part you have seen that cosecant square theta and cot square theta, that is when theta is the same angle will give 1 when subtracted. Similarly, tangent square theta when subtracted from secant square theta, the angles are same, they will also give 1. So over here, secant square theta minus tangent square theta, because the angle is same, will give 1. Similarly, on numerator we will have 1. So 1 over 1 is 1. This particular part of the portion is reduced to 1. So for the first part we have the value as 1. Now let us check what the second part will give us. The second part, it says plus of 2 sine square 39 degree into secant square 51 degree. Again friends, 39 plus 51 is nothing but 9 plus 1 10, 5 plus 3 8, and 1 of carry 90. So we are prompted to use the complementary pair. So apply this complementary pair to the second part. We have seen that secant was complementary pair of cosecant, so it will become cosecant of 90 minus 51, which obviously will be 39. So cosecant square 39. So the second part has become 2 sine square 39. Now friends, cosecant theta is 1 over sine theta, because cosecant theta is reciprocal of sine theta. So this will become 1 over sine 39. Since here it is square, so here it will also be square. So this sine square 39 cancels this sine square 39, and we are left with only 2 into 1 into 1, that is 2. So for the second part we have 2 as this calculated value, and for the third part it says sine square 45. Friends, we actually know the value of sine 45. In the previous videos it was told that its value is 1 by under root 2. So it is sine 45 whole square, that is 1 by under root 2 whole square, which will give us 1 by 2. So all in all we are having 3 values. The first is 1, the second is plus 2, and the third is minus 1 by 2. So these will give us 1 plus 2 minus 1 by 2, that is 3 minus 1 by 2, or taking the LCM, 3 means 3 by 1 and minus 1 by 2. LCM of 1 and 2 is 2, 3 2s are 6, and so the answer is 5 by 2. So friends, see, we didn't know any of the value of secant 44 or cotangent 46 and so on, but thanks to identities, thanks to complementary pairs, we can easily calculate, and we have easily calculated this particular question. Let us move on to next question. Now in this question, the question has itself asked that without using the trigonometric tables, the tables were for sine 0, sine 60, sine 90, and similarly for other trigonometric ratios. Let this question be denoted by Q. So the first part has become 2 sine 76 degree over cos 14. See, again, the only digits involved are 76 and 14. If you add up these, you will see that 6 plus 4 is 10, and 1 of carry, 7 plus 1 is 9. So it's again a complementary pair. 76 and 14. So we are prompted to apply complementary rule over here. Apply this time to numerator. So sine 76 is cos of 90 minus 76 degree over cos 14. So it will become 2 cos 14 degree, because they are complementary pairs, so 76 will be reduced to 14 when subtracted from 90 degree. So now numerator gets cancelled by denominator, leaving only 2, and hence the value of the first part is 2. Now for the second part, it says cot of 25 degree over tangent 65 degree. Again, if you add up, you will see that 25 over 65 is 5 plus 5 10, 1 of carry, 2 plus 1 3, and 6 3 9. So again, it's a complementary pair. Apply complementary rule. Since cotangent is the complementary pair with tangent, and the angles, that is, if here it is theta, it will be 90 minus theta. If here it is theta, then it will be 90 minus theta over here. So here it has become 90 minus 25 degrees over tangent 65 degrees. That is minus 2 by 5. Here it will be tangent, so tangent 65 degree over tangent 65 degree. These will cancel to get the answer 1, and we are left with minus 2 by 5 only as the reduced value of the second part. For the third part, it says minus 3 by 5 common and tangent 45. Friends, we know the value of tangent 45. It is 1. So just put tangent 45 as 1 over here. And the rest, the complementary pairs. 30 is complementary pair with 60 degree and 35 is complementary pair with 55 degree. So you can change one of the pair. Say tangent 30 degree can be written as, since it is complementary pair with cotangent, so cotangent of 90 minus 30 degree, that is, it will be cotangent 60 degree, into tangent 35 will similarly be cotangent of 90 minus 35, that is 55 degree, into tangent 55 and tangent 60. So the third part will become minus 3 by 5 cotangent 60 into cotangent 55 into tangent 55 into tangent 60. Now friends, cotangent is nothing but a reciprocal of tangent theta. That is, cotangent theta is, in this case, will become 1 over tangent 60 degree. Similarly, here it will become 1 over tangent 55 degree. So this 55 degree of tangent will cancel this part, this tangent 60 degree will cancel this part, and we will be left with only minus 3 by 5 into 1, that is minus 3 by 5 only. So the three parts are 2 minus 2 by 5 minus 3 by 5. Now for this part, which is easy to solve because the denominator is same, take minus common and the answer will be minus 5 2 plus 3, that is minus 5 by 5 or minus 1. So bringing this 2 here, we get 2 minus 1, that is, the answer here is 1. So see, without using the tables, we have calculated its answer and its value is 1 for the given question. Now let us have a last question. The question says find this value. So let it be denoted by Q. For the first part, again 65 and 25 are complementary pairs. They add up to give 90 degree. So the first part will become sine of 90 minus 65, that is 25 degree. The second part will become, it is just sine 25 degree. It cancels, and the result for the first part, the calculated value for the first part is 3/7. For the second part, we have 4/7 cos 40 degree. Again, these two are complementary pairs. So 40 plus 50 is 90. Cosecant is complementary pair of secant. So here it will be secant 90 minus 50, that is secant 40. For the denominator, 15 is complementary pair with 75 degree and 25 is complementary pair with 65 degree. So we can reduce this time the latter parts, that is leave first 3 parts, rather these 2 parts as it is, and tangent 65 will become cotangent of the complementary pair, that is 25 degree, and similarly for tangent 75 degree it will be cotangent of 15 degree. So minus 4/7 is common. In numerator, see secant theta is 1/cos theta. So here it will be cos 40 degree into 1/cos 40 degree, because secant theta is reciprocal of cos 40 degree. At the downward part, we have tangent 15 degree into cotangent 15 degree into tangent 25 degree into cotangent 25 degree, and tangent 45 degree is nothing but 1. Now since these are reciprocal counter pairs, so these will cancel, because cotangent will be 1/tangent and it will cancel this part. Similarly, tangent 25 will cancel cotangent of 25 on putting the reciprocal of cotangent 25 as tangent 1/tangent 25. So finally this part reduces to 1, denominator reduces to 1, and the second part has become just minus 4/7 into 1. From the first part we have 3/7. So all in all, 3/7 minus 4/7 is minus 1/7. So this is the solution for the given questions. So friends, in this video we have studied 5 questions which seems like calculation based questions but are not actually calculation based when the trigonometric ratios and the complementary angle pairs are applied to them, and the calculations become very easy, in fact very feeble, to solve the questions. So friends, thanks for watching Edupedia word videos.